In the figure, the length of segment PM is equal to 1 8/10 millimeters. Identify the segment bisector of segment PQ. Then find the length of segment PQ. A segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. From the diagram, you can see that segment PM and segment MQ are congruent. So, M is the midpoint of segment PQ, and the segment bisector of segment PQ is ray MT. Now, to find the length of segment PQ, you can use the segment addition postulate. Point M is between points P and Q. So, by the segment addition postulate, the length of segment PM plus the length of segment MQ equals the length of segment PQ. You are told that the length of segment PM is 1 8/10 millimeters, and because segment MQ is congruent to segment PM, the length of segment MQ is also 1 8/10 millimeters. So you can substitute 1 8/10 in for the length of segment PM and 1 8/10 in for the length of segment MQ. 1 8/10 plus 1 8/10 gives you 3 6/10. Therefore, the length of segment PQ is 3 6/10 millimeters. Point M is the midpoint of segment AB. Find the length of segment AB. To find the length of segment AB, you first need to find the value of x. In this problem, you are told that point M is the midpoint of segment AB, and you can also see from the diagram that segment AM is congruent to segment MB. So, the length of segment AM is equal to the length of segment MB. The length of segment AM is equal to 3x minus 4, and the length of segment MB is equal to 2x plus 1. So, you can substitute 3x minus 4 in for the length of segment AM, and 2x plus 1 in for the length of segment MB. Now, to solve for x, you can first subtract 2x from both sides of the equation. This gives you x minus 4 equals 1. Next, you can add 4 to both sides of the equation. This gives you x equals 5. So, the value of x is 5. Now, by the segment addition postulate, the length of segment AB is equal to the length of segment AM plus the length of segment MB. Again, you can substitute 3x minus 4 in for the length of segment AM, and 2x plus 1 in for the length of segment MB. When you combine like terms on the right-hand side of the equation, 3x plus 2x gives you 5x, and negative 4 plus 1 gives you negative 3. Now, you found the value of x to be 5. So, you can substitute 5 in for x. When you simplify, 5 times 5 gives you 25, and 25 minus 3 gives you 22. Therefore, the length of segment AB is equal to 22. A. The endpoints of segment AB are A, -8, 7, and B, 5, 1. Find the coordinates of the midpoint M. And B. The midpoint of segment PQ is M, 2, -3. One endpoint is P, 4, 1. Find the coordinates of endpoint Q. In part A, to find the coordinates of the midpoint M, you can use the midpoint formula. Let x1 equal -8, y1 equal 7, x2 equal 5, and y2 equal 1. You can substitute these values into the midpoint formula. When you simplify, -8 plus 5 gives you -3, and 7 plus 1 gives you 8. 8 divided by 2 gives you 4. So, the coordinates of the midpoint of segment AB are -3/2, 4. In part B, the coordinates of a midpoint are x1 plus x2 all divided by 2, y1 plus y2 all divided by 2. In this problem, you are told that the midpoint of segment PQ is M, 2, -3. So, the coordinates 2, -3 must equal the coordinates x1 plus x2 all divided by 2, y1 plus y2 all divided by 2. Therefore, 2 must be equal to x1 plus x2 all divided by 2, and -3 must be equal to y1 plus y2 all divided by 2. Now, you are also told that one endpoint is P, 4, 1. Let x1 equal 4 and y1 equal 1, and let the coordinates of endpoint Q be x2, y2. To find the x-coordinate of endpoint Q, you can first substitute 4 in for x1 in the equation 2 equals x1 plus x2 all divided by 2. Now, to solve for x2, you can first multiply both sides of the equation by 2. This gives you 4 equals 4 plus x2. Next, you can subtract 4 from both sides of the equation. This gives you 0 equals x2. So, the x-coordinate of endpoint Q is 0. To find the y-coordinate of endpoint Q, you can first substitute 1 in for y1 in the equation -3 equals y1 plus y2 all divided by 2. Now, to solve for y2, you can first multiply both sides of the equation by 2. This gives you -6 equals 1 plus y2. Next, you can subtract 1 from both sides of the equation. This gives you -7 equals y2. So, the y-coordinate of endpoint Q is -7. Therefore, the coordinates of endpoint Q are 0, -7. Use the information in example 4. You bicycle 5 miles east, then 2 miles north from your apartment to a friend's house. Estimate the distance between your friend's house and your school. To solve this problem, you can first model the situation using a coordinate plane with your apartment at the origin. Now, in example 4, you are told that your school is 4 miles east and 1 mile south of your apartment. This location can be represented on the coordinate plane by the point S4, -1. Also, in this problem, you are told that you bicycle 5 miles east and then 2 miles north from your apartment to a friend's house. This location can be represented on the coordinate plane by the point F52. Now, to find the distance between points F and S, or the length of segment FS, you can use the distance formula. Let x1 equal 5, y1 equal 2, x2 equal 4, and y2 equal -1. You can substitute these values into the distance formula. Now you can simplify. 4 minus 5 gives you -1, and -1 minus 2 gives you -3. -1 squared gives you +1, and -3 squared gives you +9. 1 plus 9 gives you 10. So, the length of segment FS, or the distance between points F and S, is equal to the square root of 10, which is approximately equal to 3 2/10. Therefore, the distance between your friend's house and your school is about 3 2/10 miles.